How no Shen, so much positive and joy. So definitely not, I said. Yeah, of course. I'll remember. Myopia, 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 myopia. Near distance we can see her. Far distance we can see her. Myopia, myopia, myopia. For that correction we are using. We are using. Bro, what bro? For that correction we are using. We are using concave lens, concave lens, concave lens, concave lens. Hypermetropia, 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 hypermetropia. For a distance we can see, near distance we can see. Hypermetropia, hypermetropia. For that correction we are using convex lens, convex lens, convex lens, convex lens. Convex lens, convex lens. Hypermetropia, 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 hypermetropia. For a distance we can see, near distance we can see. Hypermetropia, 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 hypermetropia. For that correction, we are using convex lens, convex lens, convex lens, convex lens. New Cartesian, sign convention, new Cartesian, sign convention. All distance measured from the pole, distance are positive along the instant trace, distance are negative opposite to instant trace, distance are positive above the principal axis, distance are negative below the principal axis. New Cartesian, sign convention, new Cartesian, sign convention. All distance are measured from the pole, distance are positive along the instant trace, distance are negative opposite to instant trace, distance are positive above the principal axis, distance are negative below the principal axis. New Cartesian, sign convention. dispersion. Splitting a white light into 7 colors. Dispersion, dispersion, dispersion. Splitting a white light into 7 colors. The band of colors is known as spectrum. Refraction of light by the atmosphere is known as atmospheric refraction. Atmospheric refraction. The phenomena involved in the formation of rainbow. The phenomena involved in the formation of rainbow. It's refraction, dispersion, internal reflection. Refraction, dispersion, internal reflection. Refraction, dispersion, internal reflection. The process of re-emission of light in all directions with different intensity is known as scattering of light. So, in the evening class, we discussed about magnetic effects of electric current. So I already completed human and colorful world and a light chapter also. So now we will discuss about electric current. Electric current. Electric current. Electric current we are discussing. Electric current. CBSE Grade 10 Physics. CBSE Grade 10 Physics. So I am talking about CBSE Grade 10 Physics. When the light ray is passing, so here CBSE Grade 10 Physics. CBSE Grade 10. CBSE grade 10 physics. CBSE grade 10 physics. CBSE grade 10 physics. CBSE grade 10 physics. So, rate of law of charge. Rate of law of charge. Rate of law of charge. So, I equal to Q by T I am taking. I equal to Q by T. I equal to SI unit of current is ampere. SI unit of current is ampere. SI unit of charge is coulomb. SI unit of charge is coulomb. SI unit of time is second. SI unit of time is second. So here I am considering, normally when you are taking, when you are considering, so the rate of law of charge, rate of law of charge is called electric current. Rate of law of charge is called electric current. So the flow of charge through unit cross section area, so per second. So flow of charge through unit cross section area per second is called electric current. I equal to Q by T. SI unit of current is ampere. SI unit of charge is coulomb. SI unit of time is second. Okay. So now, let's get into the topic. So ampere we have to write. So small letter. So on honoring the scientist we are writing ampere. So we have to write all small letters. But symbol you have to represent capital A. Coulomb, if you are considering coulomb, under SI unit of time is second. SI unit of time is second. Okay, I equal to Q by T. So inside of the conductor, so 1 ampere is nothing but 1 coulomb per 1 second. 1 ampere is nothing but 1 coulomb per 1 ampere is nothing but 1 coulomb per 1 second. 1 ampere is nothing but 1 coulomb per 1 second. So here 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area per second. 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area per second. 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area per second is called 1 ampere. So we have to denote a current A. So capital A, so symbol, so coulombs, CB are taking time second. Okay, this is the rate of law of charge. Rate of law of charge we are considering. Rate of law of charge is called electric current. Okay, so I equal to Q by T. So now we are considering inside of the conductor, there are many electrons, many charges will move. So it won't be one electron, two electron. There are bunch. So integral multiple, there are many. So n. So if you are taking plus, so positive, negative, positive, negative, positive, negative, positive, negative, so positive, negative, like that many electron, many charges will move inside of the conductor. In the form of integral multiple. So Q equal to plus or minus Ne. So Ne. So why we are taking plus or minus? Sir, why you are taking plus or minus? Why can't you go for only minus? Why can't you go for only plus? Why you are taking plus or minus? Because so charges, so positive charges will be moving, negative charges are moving inside of the conductor. So inside of the conductor, positive charges will be there, negative charges will be there. That is the reason plus or minus Ne I am considering. Plus or minus Ne I am taking. So quantization of charge is nothing but plus or minus Ne by T. So the rate of flow of charge is called electric current. I equal to plus or minus Ne by T. Here I am considering on one electron, how much charge is present? So on one electron, if you are taking on one electron 1.6 into 10 power minus 19 coulomb, on one electron 1.6 into 10 power minus 19 coulomb it will be. So in 1 coulomb, how many electrons are present? In 1 coulomb, how many electrons are present? So 1 electron equal to 1.6 into 10 power minus 19 coulomb. So on 1 electron, 1.6 into 10 power minus 19 coulomb. Okay, so charge is present. In 1 coulomb, how many electrons are present? So 1 coulomb, if you are taking 1 by 1.6 into 10 by 10, into 10 power 19. So 10 power 19, then you are getting 1 by 1 power 16 if you are taking 10. So into 10 power 19, 10 power 19. If you do it 0.625 into 10 power 9. So 1 coulomb if you are taking 6.25 into 10 power 18, 10 power 18 electrons are present. So in one coulomb this many electrons are present. In 1 coulomb this many electrons are present. Once again check once. Electric current is nothing but rate of flow of charge. Electric current is nothing but rate of flow of charge. Electric current is nothing but rate of flow of charge. I equal to Q by T. SI unit of current is ampere. SI unit of charge is coulomb. SI unit of time is second. So ampere is denoted with capital letter. So coulomb you are denoted with a C. So time anyway second. Okay. So this is about rate of flow of charge. Rate of flow of charge. Rate of flow of charge. I equal to Q by T. So inside of the 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area per second. 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area per second. So here positive charges will be there, negative charges will be moving inside of the conductor. That's why quantization of charge in rhythm plus or minus an E. It is in the form of integral multiple. So plus or minus an E I am taking. So I equal to plus or minus an E by T. So on one electron, 1.6 into 10 power minus 19 coulomb. So on 1 electron, how much charge is present? 1.6 into 10 power minus 19 coulomb. In 1 coulomb, so 1 coulomb, how many electrons are present? 6.25 into 10 power 18. 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 So on 1 electron, how much charge is present? On 1 electron, 1.6 into 10 power minus 19 coulomb. So in 1 coulomb, 6.25 into 10 power 18 electrons are present. So very, very important. So these points you need to remember, these 2 points. So that is about so this is about electrical. This is about I'm talking about. This is about okay. So electric current. Now we are going to discuss about so electrical appliances. Now we are going to discuss about electrical appliances. Okay, so electrical appliances. Okay, so I'm considering electrical appliances. Electrical appliances. So electrical appliances I'm talking. So electrical appliances. Okay, so what are those we'll discuss now. So we'll see here. So electrical appliances. So cell. So I'm talking. So first one is cell. This is cell. Okay, positive terminal, negative terminal, cell. And next one is battery. So I'm taking the battery here. So positive terminal, negative terminal. So I'm considering here is a battery. Battery. So positive terminal, negative terminal, battery I'm considering. Battery. Okay. So third one is open switch. I'm taking this open switch. And next one, fourth one is closed switch. So I'm taking this a closed switch. And the fifth one, this is the open switch, closed switch. Next one, resistor. This is the resistor. Next one, rheostat. Sixth one, rheostat. So rheostat is nothing but rheostat. Rheostat. Cell, battery, open switch, closed switch, resistor. Resistor is a device which opposes the electric current. Resistor is a device which opposes the electric current. Rheostat is a device. Rheostat is a device. So without changing the voltage source, it regulates the current. Without changing the voltage source, it regulates the current. Without changing the voltage source, it regulates the current. Without changing the voltage source, it regulates the current. So next one, see, seventh one I am talking. So ammeter, 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 ammeter. Next one, voltmeter, voltmeter, ammeter, voltmeter, ammeter. Next one, bulb, 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 bulb. Tenth one, tenth one, wire joining, wire joining. 11th one, wire crossing, wire crossing, wire crossing, wire crossing. So here I am considering here I am considering here. I am considering, I am telling cell, battery, open switch, closed switch, resistor, rheostat, ammeter, voltmeter, bulb, wire joining, wire crossing. That's it. That is about electrical appliances. Electrical appliances. Cell, battery, open switch, closed switch. So cell, battery, battery, open switch, closed switch, resistor. Resistor is a device which is used to oppose electric current in the circuit. Resistor is a device which is used to oppose the electric current in the circuit. SI unit of resistance is ohm. SI unit of resistance is ohm. SI unit of resistance is ohm. Rheostat is nothing but without changing the voltage source, it can regulate the current. Without changing the voltage source, it regulates the current is called rheostat. Ammeter. Ammeter is used to measure the electric current. Ammeter is used to measure the electric current. Ammeter is connected in series combination to the circuit. Voltmeter is used to measure the potential difference. Voltmeter is used to measure the potential difference. Voltmeter is connected in circuit parallel combination. So next one, we are going to the bulb opens, wire joining and wire crossing. This is about electrical appliances. Come on, we are going to discuss about potential difference and electrical potential. Are you ready? Be ready for the class. Potential difference and electrical potential. Electrical potential and potential difference. Electrical potential difference. So meanwhile, we'll discuss about electrical circuit. What is electric circuit? A closed and continuous path of an electric current. A closed and continuous path of an electric current is known as electric circuit. A closed and continuous path of an electric current is called an electric circuit. A closed and continuous path of an electric current is known as an electric circuit. So, what are the elements are there in electrical circuit? One, I am taking the battery. So, I am considering the switch. And next one, ammeter. Ammeter I'm taking. Ammeter I'm taking. Bulb. Bulb I'm considering. Bulb I'm considering. Current is passing positive terminal, negative terminal. Current is passing positive. So boy, bulb is glowing. Bulb is glowing. Yes or no? Yes or no? Current is flowing. Bulb is glowing. Now you can see. Now you can see. Now you can see. Now we can see. So before finding electron proton, before finding electron proton, before finding electron proton, so current will be taken as the direction of flow of positive charges. So scientists were already given the statement, that is, so the flow of positive charges will be considered as a, so current direction. After finding electron proton, so they understand, they identified that the flow of electrons, the flow of electrons, the flow of electrons, the flow of electrons, because of the electrons flow movement, because of the electrons movement only current will pass inside of the conductor. Because of the electrons movement only current will pass inside of the conductor. So after this, instead of changing everything, better we will change the statement. Instead of changing everything, better we will change the statement. That's why they change that conventional current and electric current. Conventional current and electric current. First one I'm taking conventional current. Conventional current. Conventional current. Second one is electric current. Electric current. So what is meant by conventional current? The flow of positive charges. The flow of positive charges. The flow of positive charges will be considered as a conventional current. Conventional current direction will be taken from positive terminal to negative terminal. Positive terminal to negative terminal. Positive terminal to negative terminal. The flow of positive charges direction will be considered as a conventional current direction. Electrons direction. Electrons will move from low potential to high potential. Electrons will move from low potential to high potential. Electrons will move from low potential to high potential. Positive charges will move from positive terminal to negative terminal. Positive terminal to negative terminal. Positive terminal to negative terminals. So see here, positive charges, positive terminal have high potential. Positive terminal have high potential. Negative terminal have low potential. Positive terminal have high potential. Negative terminal have low potential. Electrons will move from low potential to high potential. Electrons will move from low potential to high potential. Electrons will move from low potential to high potential. Low potential to high potential. So positive charges will move from positive terminal to negative terminal. Positive terminal to negative terminal. Positive terminal to negative terminal. Do you know conventional current direction? Flow of positive charges. Electric current, flow of electrons. Electrons will move from low potential to high potential. Electrons will move from low potential to high potential. Remember, do you know that temperature will move from high temperature region to low temperature region? Yes or no? Temperature. Yes or no? Yes or no? Charges will move from electric current. That is not but conventional current. Conventional current will move from high potential to low potential. High potential to low potential. But electrons will move from low potential to high potential. Remember that. Electrons will move from low potential to high potential. Very, very important. Very, very important. One question will come. Electrons will move from low potential to high potential. Remember. Right. So next one. So next one we'll go and discuss about potential difference and electrical potential. 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 Yes, yes. What is potential difference? Potential difference is work done to bring unit positive charge from one point to another point within the conductor. Potential difference is work done to bring unit positive charge from one point to another point within the conductor is called potential difference. Potential difference. There are two types of potential. One is potential difference, another one is electrical potential. Electrical potential we will discuss now. Shall we discuss? There are two types. One is potential difference, electrical potential. So like we will discuss the next one. Potential difference will discuss. Potential difference. 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 Work done to bring unit positive charge from one point to another point within the conductor. Work done to bring unit positive charge from one point to another point within the conductor is called potential difference. Potential difference. I am taking the conductor here. This is the conductor. This is the point A and point B. So we are taking the positive charge. We are doing some work. We are doing some work to bring unit positive charge. We are doing some work to bring unit positive charge from one point to another point. Within the conductor. From one point to another point within the conductor is called potential difference. Work done to bring unit positive charge from one point to another point within the conductor is called potential difference. V equal to W by Q. What is the SI unit of potential difference? Volt. SI unit of potential difference is volt. What is the SI unit of work? SI unit of work is joule. SI unit of work is joule. SI unit of work is joule. SI unit of charge is coulomb. SI unit of charge is coulomb. 1 volt is defined as 1 joule of work is done to bring 1 coulomb of charge. 1 volt is defined as 1 joule of work is done to bring 1 coulomb of charge from one point to another point. 1 volt is defined as 1 joule of work is done to bring 1 coulomb of charge from one point to another point within the conductor. Within the conductor is called potential difference. Coming to the electrical potential. Electrical potential. Work done to bring unit positive charge from infinity to the required field. So I am taking this is the required field. So this is the positive charge. So this is the infinity I am taking. We are doing some work to bring unit positive charge from infinity to the required field. From infinity to the required field. Work done to bring unit positive charge. From infinity to the required field. From infinity to the required field is called electrical potential. So 1 volt equal to W by Q. Same formula we are using. Same formula we are using. So potential difference is nothing but work done to bring unit positive charge from one point to another point within the conductor. Work done to bring unit positive charge from one point to another point within the conductor is called potential difference. Electrical potential. Electrical potential. Electrical potential. Work done to bring unit positive charge from infinity to the required field, from infinity to the required field, from infinity to the required field, from infinity to the required field is called electrical potential. Electrical potential. Electrical potential. Electrical potential. Electrical potential. Electrical potential. That is about potential difference and electrical potential. Potential difference and electrical potential. Is it clear or not? Is it clear or not? So do you get it or not? So electrical potential and potential difference. 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 Electrical potential. 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 Potential difference. So that is about electrical potential difference. Next one we will discuss about Ohm's law. Ohm's law. Ohm's law. Come on. Ohm's law. 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 The potential difference, the potential difference, the potential difference, the potential difference across the ends of the given metallic conductor, the potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it. The potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it. Current flowing through it. Current flowing through it. Current flowing in the circuit. Current flowing inside of the circuit. Inside of the wire. Current is flowing in the circuit. Current is flowing in the circuit. I am considering positive terminal, negative terminal, 1.5 volts, 1.5 volts, 1.5 volts, 1.5 volts. Current is passing. So positive terminal, negative terminal, positive terminal, negative terminal. Current is passing. So I am considering here. Okay. So now you can see the potential difference. The potential difference across the ends of the given metallic conductor, the potential difference across the ends of the potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it. The potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it. V is directly proportional to I. V equal to IR at constant temperature. At constant temperature, the potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it. At constant temperature and physical conditions also same. At constant temperature, the potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it. V is directly proportional to I. V equal to IR. V equal to IR. So now materials required. Materials required. Materials required. What are the materials required? What are the materials required? Materials required. Okay. So first you have to consider First you have to consider, first one I'm taking, four cells, 1.5 volts each. Second one, 4 cells, 1.5 volts each. Nichrome wire. Nichrome wire is an alloy of nickel, chromium, manganese and iron metals, 0.5 meter length. And coming to the third one, ammeter, fourth one, voltmeter, fifth one, first one is 4 cells, 1.5 volts each, 4 cells. Okay, so 4 cells, 1.5 volts each, 4 cells, 1.5 volts each. Nichrome wire is an alloy of nickel, chromium, manganese and iron metals. Ammeter, voltmeter, switch, and sixth one, connecting wires. Connecting wires. Okay, so this is about materials required. What are the materials are required for doing activity? These are the materials required. Now you can see procedure. So you have to connect one cell. First you have to connect one cell. First you have to connect one cell. One cell and note down the reading of ammeter and voltmeter. First you have to connect one cell and note down the reading of ammeter and voltmeter. And second, connect to two cells and note down the reading of ammeter and voltmeter. And next one coming to 3 and 4. So repeat the process for 3 and 4. Repeat the process for 3 and 4 and mention the so identify the reading of ammeter and voltmeter mentioned in the tabular form given below. If you draw the graph, VI graph, so next one. So first connect one cell and note down the reading of ammeter and voltmeter. And then next connect two cells and note down the reading of ammeter and voltmeter. Next repeat the process, continue the process for 3 and 4. And you mention in the tabular form given below. If you draw the graph for VI, it shows the linear. So right, starting from origin. So this is for ohmic conductor, the substances which obey Ohm's law. The substances are the conductors which obey Ohm's law, those are called ohmic conductors. So the conductor which obey Ohm's law, those are called ohmic conductor. The conductor which does not obey Ohm's law, those are called non-ohmic conductor. The conductors which obey Ohm's law, those are called ohmic conductor. The conductor which does not obey Ohm's law, those are called non-ohmic conductors, non-ohmic conductor, the substances which obey Ohm's law, the conductors which obey Ohm's law, those are called ohmic conductor. The conductor which does not obey Ohm's law, those are called non-ohmic conductors. Non-ohmic conductor, right? Non-ohmic conductor. So this is about Ohm's law. This is about Ohm's law. Ohm's law. Next one we are going to discuss about resistors. Resistance. Resistance will discuss. Resistance. So resistance R is directly proportional to length of the conductor. Resistance R is directly proportional to length of the conductor. R is inversely proportional to area. R is directly proportional to L by A. R equal to rho into L by A. So rho equal to RA by L. Rho equal to RA by L. Rho equal to RA by L. Okay. So once again, resistance is directly proportional to length of the conductor. Resistance is directly proportional to length of the conductor. Resistance is inversely proportional to area of the conductor. Resistance is directly proportional to length of the conductor. Resistance is inversely proportional to area of the conductor. R if you are taking R is directly proportional to R is inversely proportional to area. R is directly proportional to L by R equal to rho into L by A. So here you can observe R is a resistance, R is a resistance, R is the resistance, and rho is the resistivity, rho is the resistivity, rho is the resistivity, resistivity I am taking, resistivity I am considering. R is the resistance, rho is the resistivity. R is the resistance, rho is the resistivity. R is the resistance, rho is the resistivity. So now rho SI unit of resistivity is SI unit of resistance is ohm. SI unit of area is meter square. SI unit of length is meter. Meter get cancelled. Resistivity is equal to ohm meter. Resistivity is equal to ohm meter. Resistivity is equal to ohm meter. So resistance depends on length of the conductor. Resistance depends on area of the conductor. Resistance, okay, depends on temperature and material of the medium also. Temperature and material of the medium also. Temperature and material of the medium also. SI unit of resistivity. Very, very important. This question is very, very important. They will ask for 2 marks. Including derivation right from starting to derivation to up to here right from starting derivation to up to here. So they will ask about what are the factor depends on resistance, give the relation between resistance and resistivity. So derive the SI unit of resistivity, derive the SI unit of resistivity, like that they will ask. So that time you have to derive resistance is directly proportional to length of the conductor. Resistance is inversely proportional to area of the conductor. R is directly proportional to L by A. R equal to rho into L by A. Rho equal to RA by L. Rho equal to RA by L. Rho equal to RA by L. Rho equal to ohm meter square by meter. Meter get cancel. Ohm equal to, so resistivity rho equal to ohm meter. Resistivity rho equal to ohm meter. Once again, so R equal to rho into L by A. R equal to rho into L by A. Rho equal to RA by L. Rho equal to RA by L. R rho equal to ohm meter square by meter. Meter get cancelled. Meter get cancelled. Rho equal to ohm meter. Rho equal to ohm meter. Rho equal to ohm meter. SI unit of resistivity. SI unit of resistivity. SI unit of resistivity is ohm meter. SI unit of resistivity is ohm meter. SI unit of resistivity is ohm meter. Now we will discuss about so resistors are connected in series combination. Resistors are connected in series combination. And actually difference between resistance and resistivity we will discuss. Difference between resistance and resistivity. So resistance and resistivity. So R equal to rho into L by A. First one, rho equal to RA by L. Second one, so SI unit of resistance is ohm. So third one, so here ohm meter. Here symbol of ohm. Fourth one, resistance depends on length of the conductor and area. Depends. So does not depend on length and area. So fifth one, resistance depends on temperature. Resistivity depends on temperature. Sixth one, material of the conductor. Resistance depends on material of the conductor. So here also material. Okay. So that's enough. Resistance R equal to rho into L by A. Resistance, SI unit of resistance is ohm. SI unit of resistance is ohm. SI unit of resistivity is ohm meter. Symbol I am taking. So resistance depends on length and the area of the conductor. Resistance depends on length and area of the conductor. Resistivity does not depend on length and area. So resistance depends on temperature. Resistivity depends on temperature. Resistance depends on material of the conductor. Resistivity also depends on material of the conductor. Right? So next one we are going to discuss about one more. Resistors are connected in series combination. Resistors are connected in series combination. So now small break. So need small break. Now resistors are connected in series combination. So now resistors are connected. Resistors are connected in series combination. So now you can see here. Now you can see. So I'm taking one resistor like this. So resistors are connected in such a way that so you can observe. So throughout the path current is same. Throughout the path current is same. Throughout the path current is same. Yes or no? Throughout the path current is same. R1, R2, R3. So if the current is passing like this. Okay, from Ohm's law V equal to IR. From Ohm's law V equal to IR. So in this current is same. So throughout the path current is same. Throughout the path current is same. Throughout the path current is same. That's why is equal to I1 equal to I2 equal to I3 equal to I, because current is same in series combination. There is one question. That question is, so in which physical quantity is constant? Which physical quantity is constant in series combination? Which physical quantity is constant in series combination? So in series combination, current is the physical quantity. Current is the physical quantity which is constant. Okay? So throughout the path, current is constant in series combination. Current is constant in series combination, right? current is constant in series combination. Is equal to I1 equal to I2 equal to I3 equal to I. So whereas potential difference is different. Potential difference V1, V2, V3. So V is different. So Vs equal to V1 equal Vs equal to V1 plus Vs equal to V1 plus V2 plus V3. So Vs equal to V1 plus V2 plus V3. So Vs equal to V1 plus V2 plus V3. So IRs equal to IR1 plus IR2 plus IR3. So I we can take common. Rs equal to, so I we are taking common R1 plus R2 plus R3. So I get cancelled. I get cancelled. Then Rs equal to Rs equal to Rs equal to R1 plus R2 plus R3. So all resistors are correct now. R1, R2, R3. So in series combination, 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 in series combination we can take. So if n number of resistors are connected, so the total resistance is NR. Rs equal to NR. So in series combination, all resistors are connected. So throughout the path current is same. Throughout the path current is same. Throughout the path current is same. So that is the reason Is equal to I1 equal to I2 equal to I3 equal to I. So Vs potential difference Vs equal to V1 plus V2 plus V3. So IRs equal to IR1 plus IR2 plus IR3. IRs equal to I common R1 plus R2 plus R3. I get cancelled. 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 The remaining value is Rs equal to R1 plus R2 plus R3. Rs equal to R1 plus R2 plus R3. Rs equal to R1 plus R2 plus R3. If n number of resistors are connected in series combination, if n number of resistors are connected in series combination, Rs equal to NR. If n number of resistors are connected in series combination, if n number of resistors are connected in series combination, if n number of resistors are connected in series combination, Rs equal to R1 plus R2 plus R3. So Rs equal to NR. Rs equal to NR. Rs equal to NR. Rs equal to NR. If n number of reps. So now we will discuss about parallel combination. Now we will discuss about parallel combination. So resistors are connected in parallel combination. Resistors are connected in parallel combination. We'll discuss now. We'll discuss now. I am taking. So resistors are connected in parallel combination. Resistors are connected in parallel combination. Okay. So resistors are connected in parallel combination. We are discussing now. So we'll see now. So here I am considering. So across this one, I am taking potential difference. So R1, this is R1. R1 I am taking. R1 I am considering R1, R2, R3. So here, whatever the current is flowing, okay. So if the current is flowing inside of the conductor, if the current is flowing inside of the conductor, you can see. So current is dividing into so I1, I2, I3. I1, I2, I3, I1, I2, I3. So current will be divided across R1, R2, R3. Current will be divided across R1, R2, R3, R1, R2, R3. R1, R2, R3. So from Ohm's law V equal to IR, from Ohm's law V equal to IR, I equal to V by R, I equal to V by R, I equal to V by R. So now here in this case Vp equal to V1 equal to V2 equal to V3, and also that is nothing but V. So we can take so potential difference across potential difference in parallel combination, potential difference in parallel combination. So Vs equal to so Vp. So Vp equal to V1 equal to V2 equal to V3 equal to V. So now I am considering here Ip equal to so I1 plus I2 plus I3. So Ip equal to I1 plus I2 plus I3. Ip equal to I1 plus I2 plus I3. Current we have to add. Okay. Current we have to add. So now we are adding the current. Then how much you'll get? So in the place of Ip, we can take V by Rp. So V by R1 plus V by R2 plus V by R3. So shall we take V common? Shall we take V common? So take V common now. So we are taking common 1 by Rp equal to so 1 by R1 plus 1 by R2 plus 1 by R3. So we will get cancelled. So the final formula is 1 by Rp equal to 1 by R1 plus 1 by R2 plus 1 by R3. So this is the derivation. This is the derivation. This is the derivation. This is the derivation. Okay. So this is the derivation. So this is the derivation about resistors are connected in parallel combination. Resistors are connected in parallel combination. Right? Yes. Now we can see if n number of resistors are connected in parallel combination, Rp equal to N by R, then we'll get Rp equal to R by N. So this is the formula. If n number of resistors are connected in parallel combination, if n number of resistors are connected in parallel combination, if n number of resistors are connected in parallel combination, if n number of resistors are connected in parallel combination, if n number of resistors are connected in parallel combination, 1 by Rp equal to N by R. 1 by Rp equal to N by R. Rp equal to R by N. Rp equal to R by N. So this is about resistors are connected in parallel combination. Resistors are connected in parallel combination. Resistors are connected in parallel combination. Right? So next we are going to discuss about one more. So now we are going to discuss about heating effect of electric current. Heating effect of electric current. Heating effect of electric current. We know potential difference. Potential difference V equal to W by Q. Potential difference V equal to W by Q. So W equal to VQ. So P equal to rate of electrical work, rate of doing work, rate of doing work. Okay. So P equal to W by T. So now W equal to VQ by T. So P equal to V into Q by T. So Q by T is nothing but I. Okay. So P equal to VI. P equal to VI. Right. P equal to VI. Now energy if you are taking energy, so E equal to P into T, that is nothing but V into T. V equal to IR, substitute here in the place of V. So whatever the heat is produced, that will become heat. IR into I into T, that is nothing but I square RT. So heat produced in the conductor H equal to I square RT. So heat produced in the conductor is equal to I square RT. So that is the formula. Is it clear? So once again, heat produced. So V equal to W by Q. V equal to W by Q. W equal to VQ. P equal to W by T. W equal to VQ by T. So we know I equal to Q by T. SI rate of current is rate of flow of charge is called current. P equal to W by T. So P equal to V into Q by T, that is nothing but I. P equal to VI. So energy is given P into T, energy equal to P into T, whatever be given, energy equal to P into T. So potential difference is B equal to IR, B equal to IR, V equal to IR. So here, what are the heat is produced in the conductor? Okay, so H equal to I square R, H equal to I square RT. It is also known as Joule's law of heating. H equal to I square RT. H equal to I square RT. It is also known as Joule's law of heating. Joule's law of heating. H equal to I square RT. It is also known as Joule's law of heating. Joule's law of heating. Okay, heat produced in the conductor. Heat produced in the conductor. Heat produced in the conductor is directly proportional to square of current. Heat produced in the conductor is directly proportional to square of current. Heat produced is directly proportional to resistance. Heat produced is directly proportional to time. Is directly proportional to time. So this is about electric current, electric current, electric current, electric current, electric current, electric current. Okay, right? So the source of energy continuously gets dissipated entirely in the form of it is called heating effect of electric current. A source of energy continuously gets dissipated entirely in the form of heat is called heating effect of electric current. H is directly proportional to I square. H is directly proportional to resistance. H is directly proportional to time. H is directly proportional to time. Yes or no? Yes or no? Electric current. Rate of flow of charge. I SI unit of current is ampere. SI unit of charge is coulomb. SI unit of time is second. Okay. So this is about electric current, heating effect of electric current. So the source of energy continuously gets dissipated entirely in the form of heat is known as heating effect of electric current, that is also known as Joule's law of heating. Okay, so H is directly proportional to I square, H is directly proportional to resistance, H is directly proportional to time. Okay, done. So next we will discuss about everything completed almost. Next, short circuit, direct contact of live and neutral wire takes place. Then it will have, so fire occurs in the building. So heavy amount of current will be drawn from the mains. Okay, so it may leads to the fire in the building. And next one, one more, overloading. Overloading is nothing but, so high voltage appliances on at a time, heavy amount of current will be drawn from the main, so it leads to the short circuit. Okay, and the live wire potential is live wire potential is 220, neutral wire potential is 0, earth wire is potential is 0. Difference between live wire and neutral wire is 220 in India. So difference between live wire and neutral wire is 220 volt. Okay, so that is about that's enough. So maximum we discussed about electric current, heating effect, electrical power, and commercial unit of energy kilowatt hour. Commercial unit of energy is kilowatt hour. Okay, so this is about today class. Thank you so much for joining and attending the class. So this is about Shiva sir, Student the Brand. If you like this video, do like, share, and subscribe to Student the Brand. Okay, so if it is possible, we will do some work. So I'll give the problems. We will do. Yes. Heating effect of electric current applications. Applications of heating effect of electric current. Electrical cooker, electrical iron. So like you can see, room heaters, electrical oven. These are the heating effect of electric current. Okay. So applications of heating effect of electric current. Applications of heating effect of electric current. Okay, so thank you so much. Now, after 10 minutes, after 10 minutes, so I'll start to talk with Shiva sir, live class. So discussion like a normal general meeting, like a normal discussion, talk with Shiva sir. 10:50 or 10:55. Now already 10, almost 10:41. 10:41. Okay, so I'll start at 10:55. 10:55. Okay, so after 13 minutes. After 13 minutes, you can join and discuss with me. So you can talk with me. So thank you so much. This is your Shiva sir. If you like this content, if you like this explanation, if you like the channel, do like, share, and subscribe to Student the Brand. So thank you so much for your joining and attending and me interacting with me. So this is your Shiva sir signing off.